Okay, moving on to Unit 11, Lesson 2. Now we're talking about simplifying radicals, and the first lesson is about the product property. Okay? And your objective is right here. Let's go ahead and get started. First couple things we need to know is what a simplified radical looks like. Okay? We have to simplify a radical if it does not follow all three of these criteria. Okay? So there cannot be a perfect square factor other than 1 underneath the square root. So for example, the square root of 4 is not simplified all the way because the number underneath the square root is a perfect square. That equals 2. Okay? So we cannot have a perfect square factor underneath here. Alright? And we'll talk about what that means a little more. Number 2, there are no fractions under the square root symbol. Okay? So for example, the square root of 16 over 25. Okay, I cannot have that. Okay, we can't have fractions underneath the square root symbol. So we'll learn about this in the next lesson, but what I would do is break it apart and make it the square root of 16 over the square root of 25. So it would be 4 over 5. And now it would be simplified. Okay, or an example like this, where I would have the square root of, let's say, 14 over 16. Okay, well I would take the square root of 14 over the square root of 16, so it would be like the square root of 14 over 4. Again, can't have fractions underneath the square root. So if I look here, I took my fraction and got rid of it, and here I had a fraction underneath the square root, and this time I don't have a fraction underneath the square root, even though my answer is as a fraction. Okay, and I also cannot have radicals appear in the denominator of a fraction. So for example, kind of like I did in the example above, if I had something like this, let's say it was 4 over the square root of 4, okay, that's not simplified. Okay, I cannot have a radical in the denominator, so I would take 4 over, and the square root of 4 is 2, which equals 2. Okay, so a radical is only simplified if it follows all these criteria. So just like we simplified fractions, we should always simplify radicals to make them easier to work with. And this is the first lesson in that. Okay, let's go ahead and go on to some examples and talk about the product property. Okay, the product property is right here. It says that the square root of something times another thing, okay, if I have two things multiplied underneath a square root, then I can break them apart and say that that's the same as the square root of the first thing times the square root of the second thing. Okay, now, for example, the square root of 24. Okay, well, the square root of 24 would be like, let's go ahead and say the square root of 4 times the square root of 6. Okay, because 4 times 6 gives me 24. So I can break this 24 apart into things that are factors of them. Okay, and now I know the square root of 4, that's 2, and I don't know the square root of 6, so I just leave it. So the square root of 24 is the same as the square root of 4 times the square root of 6, and the square root of 4 times the square root of 6 is the same as 2 times the square root of 6. And that's our simplified answer, okay? Because it follows the three criteria I gave you on the last slide, and again, we'll talk more about that in a second. Okay, same thing here. I've got two things multiplied together, okay? So I can rewrite them like this up here, where I can write them under one radical. So the square root of 8 times the square root of 3 is the same as the square root of 8 times 3, which is the square root of 24. And again, that breaks apart into 2 times the square root of 6. Okay, we just did that work above. Alright, now let's go ahead and do some examples of when we're going to be using this product property and how to go about it. Okay, here's two examples, and we're going to do these same two examples again after this slide. And the first method that we're going to use is just what we're going to call kind of the break apart method, okay, where our radical is not all the way simplified, again, if it doesn't follow the three criteria. Okay, the first criteria is that there can't be any perfect square factors underneath the radical. So for example, 50 is not a number that's a prime number, so it can be broken apart into factors like 1 times 50, okay, or 2 times 25, or 5 times 10. Okay, Now, if any of the factors of 50 are perfect squares, then my radical is not simplified. So when I look, 1 is a perfect square and 50 is a perfect square, but we said that that the radical is not simplified if it has a perfect square factor other than 1. Okay, so we're not taking 1 into account. If I look here, though, I've got 2 times 25 gives me 50. And 25 is a perfect square number, which means this can be broken apart yet. Okay, so I'm going to break this apart into the square root of 2 times the square root of 25. Okay, because it's got a perfect square factor right here. And a good thing about this now is that this is the square root of 2 times, and the square root of 25, I know, that's 5. Now, I never want you to leave your answers written like this, okay? Anytime you've got a number that's not a radical, okay, go ahead and put it in front. So we're going to rewrite our answer like this, as 5 times the square root of 2. Kind of pretending like this is a variable, okay? And we always want our variables last. Okay, remember? So like, we wouldn't write x times 5, we'd write 5x. So here we're not going to write the square root of 2 times 5, we're going to write 5 square root of 2 as our simplified answer. And now if we check those three things, we've got a number underneath here that doesn't have any perfect square factors. The only way I can get this is 1 times 2, so I can't break it apart anymore. There's no fraction underneath the radical, and there's no fraction with the radical in the denominator, so we are simplified. Okay, same thing here. We're going to go to the other example, and again, just this break apart method. And we can list factors of 48. I know 1 times 48. I know 2 times 24, and if I look at those factors, neither one of those are a perfect square. I could do 3 times 16. Okay, I could do 4 times 12 as well. I could do 6 times 8. All those factors will give me 48. Okay, now I'm going to look for pairs of factors that have a perfect square in them. Again, 1 and 48 aren't perfect squares, or well, 1 is, but we're not counting that. 2 and 24 aren't. Okay, 3 and 16 have a perfect square, because 16 is a perfect square. And 4 and 12 have a perfect square as well, because 4 is a perfect square. And 6 times 8, neither one of those are perfect squares. So I need to pick one of these two to break apart, and I'm always going to pick the one with the highest perfect square number, so I will have to do less simplifying at the end. So I'm going to go ahead and pick the 3 times 16 version. So the square root of 48 is the same as the square root of 16 times the square root of 3. Well, the square root of 16 is 4. The square root of 3 doesn't have any perfect square factors, so we're just going to leave it and say it's 4 times the square root of 3. And now our radical is simplified because there's no perfect square factors of 3. Just 1 times 3. Okay, now we could have broken this apart with 4 times 12, and I just want to show you that real quick and see what's going to happen here. Okay, let's say we did the square root of 4 times the square root of 12, because I know 4 is a perfect square factor. Well, the square root of 4 is 2, but the problem is that 12 has a perfect square factor in it, because 4 times 3 gives me 12. So then I would have to say that it's 2 times the square root of 4 times the square root of 3. And then I'd have to say, well, this is 2 times, and the square root of 4 is 2, times the square root of 3. And 2 times 2 is 4 times the square root of 3. So it works out, we get the same answer, but notice there's more steps. So you want to try to figure out the highest perfect square number that goes into this, so that we have less simplifying to do. Okay, less steps, and that's a good thing. Alright, let's go on to the next slide where we're going to do a different method with these same two examples. Now this method is called the prime factorization method, okay? So for those of us who aren't as good figuring out perfect square numbers, okay, or remembering what the perfect squares are, this method is a great way to get around that. And here's what we're going to do. I'm just going to break down 50 into its prime factors with a factor tree, okay? We learned those a long time ago. Okay, so 50 is 2 times 25. And we can break down 25 into 5 times 5. Okay, and those are all prime numbers now. So the square root of 50 is the same as, and then we're going to rewrite this as the square root of our prime factors of 50. 2 times 5 times 5. Okay? Well, once we've done that, we're going to look for groups of numbers or pairs of numbers that go together. So for example, 5 and 5 are the same. Okay, so I'm going to look at this pair of numbers. and just pull that out and put that outside the radical. So I'm going to put 5, and then the rest of it is going to stay underneath, times the square root of 2, which is the exact same answer that we got on the last slide, okay, for the square root of 50. Okay, now let's do the square root of 48. Same thing, factor tree method. Okay, we can break this apart. However, let's just go ahead and do 6 times 8 for something different. Okay, well 6 can be broken apart into 2 times 3, and 8 is 2 times 4. Then 4 gets broken apart into 2 times 2. So now we're going to take our prime numbers and let's go ahead and write them in order, okay, underneath the radical. So I've got 1, 2, 3, 4 2's, and a 3. So now again, I'm going to look for pairs of numbers to pull outside the radical. Well, I've got a set of 2's. I've got another set of 2's, so I'm going to put 2 times 2. And then 3 does not have a pair, so it's going to stay underneath the radical. And then I'm just going to multiply the numbers I have outside the radical. So 2 times 2 is 4, times the square root of 3. Okay? Same answer, just different method. Okay, again, you can use whichever method, the break apart method, if you know perfect square numbers pretty well. And if you don't know perfect square numbers very well, then this prime factorization method works great. Okay, and it's pretty easy and pretty quick too. Now let's go on to one last example. Okay, for this example, we're going to go ahead and use both methods. Okay, let's use the break apart method first. So this says 1/2 times the square root of 72. So I'm going to leave the 1/2, okay, times the square root of 72. So I need to figure out some perfect square factors of 72. Well, I know 72 can break down into 1 times 72. It can break down to 2 times 36. And voila, I've got a perfect square number right here. That's going to be the highest perfect square that goes into 72. Okay? So this is going to be the same as 1/2 times the square root of 36 times the square root of 2. Okay, well, 1/2 times the square root of 36 is 6, times the square root of 2 is simplified. Okay, we can't break that apart anymore. And now I'm just going to multiply what's left. 1/2 times 6 is 3, times the square root of 2. Okay, that's 1/2 of the square root of 72. It's 3 times the square root of 2. And let's go ahead and do the same example again using the factor tree method. Let's go ahead and break 72 apart. Oh, and I don't know, let's just do 12 times 6. Just because. Well, 12 breaks apart into 3 times 4. And 4 breaks apart into 2 times 2. And then 6 breaks apart into 2 times 3. So I've got 1/2 times, and when I'm going to write my big square root symbol, again, I'm putting the prime factors only in order from smallest to largest. So I've got 1, 2, 3 2's. And then 2 3's. So again, I'm going to use groups here, or pairs. So I've got 1/2 times 2 can be pulled out, and then 3 can be pulled out, and all I have left under the radical is the square root of 2. So I'm going to go ahead and multiply this stuff outside the radical together. Well, 1/2 of 2 is 1, and 1 times 3 is 3, so it's 3 times the square root of 2. Okay? And that is your lesson on simplifying, or your first lesson on simplifying radicals, dealing with the product property. Okay? So good luck on your homework.